universe is full of wonders. Powerful telescopes show great galaxies scattered throughout space, each containing countless masses of stars. The galaxies slowly rotate over hundreds of millions of years. Some galaxies shoot out jets of gas from their centers, where invisible black holes may lurk. Some stars come in large groups, and others in families of 2 or 3 that orbit around each other in a complex dance. Closer still are planets such as Venus that we can explore with space probes, which reveal breathtaking landscapes of craters, valleys, and mountains. In the daytime, we see one star, our own sun, a seething ball of gas. And this is the sun as seen by a satellite that detects X-rays from the storms and explosions on its surface. Nightfall, and the stars come out. A giant radio telescope busies itself detecting radio noise from objects in space. Radio telescopes can work during the day as well as at night. The telescopes that collect light from the stars need clear, dark skies, and so astronomers put their observatories on tops of high mountains, above most of the clouds, air pollution, and city lights. The clearest views of all are obtained above the atmosphere. The Hubble Space Telescope is the largest telescope ever launched, and from its vantage point in orbit, it shows the sky more clearly than much larger telescopes on Earth. Satellites in orbit pick up wavelengths other than light that do not pass through our atmosphere, giving us completely new views of the universe. The urge to study the sky is as old as humanity itself. Stonehenge on Salisbury Plain in England may have been the first observatory. Thousands of years ago, ancient Britons built this stone circle to follow the yearly motion of the sun around the sky. A simple calendar of the passing seasons that may have told them when to sow their crops, when to harvest them, and when to hold their festivals. The builders of Stonehenge knew the changing appearance of the sky. Every night, the stars wheel overhead as the Earth spins, seen here in time-lapse. This is the full moon casting its silvery light over the landscape below. Thousands of years ago, the moon was worshipped as a goddess. Now, humans have landed on it and found that it is a lifeless ball of dark gray rock. On dark, moonless nights, we can see a faint band of light crossing the sky. This is the Milky Way, and it consists of distant stars in our galaxy. The Milky Way is densest and brightest toward the center of our galaxy. Here seen setting behind a tree. Zooming in on the center of the galaxy, we see swarms of stars, overlain by patches of dark dust that block our view. Galaxies come in groups, ranging in size from a handful to many thousands. A Astronomers plotting the position of galaxy groups have found that they form strands around great voids in the universe. Each dot in this diagram is not a single galaxy, but a whole group of galaxies. Distances in space are so great that astronomers measure them by how long a beam of light would take to cross them. Light, which travels at over 186,000 miles per second, can go 7 times around the Earth in 1 second. To the moon and back in 2.5 seconds. Over 8 minutes from the sun to the Earth. 5 hours from the sun to the most distant planet. 4.3 years to the nearest star. From our sun to the center of the galaxy takes 30,000 years. To cross the galaxy from one side to the other takes 100,000 years. From our galaxy to its near neighbor, the Andromeda Galaxy, takes over 2 million years. And to the most distant objects visible in the universe, called quasars, would take 15 billion years, over 3 times the age of the Earth. The distant region of the quasars is of particular interest to astronomers studying the origin of the universe. Quasars are thought to be the intensely brilliant centers of young galaxies, seen shortly after the universe was born in a giant explosion called the Big Bang. In 1992, a satellite called COBE, the Cosmic Background Explorer, detected traces of heat left over from the Big Bang itself. The Big Bang occurred about 15 billion years ago. In one incandescent moment, the universe erupted into being. It began to expand from a microscopic dot to the vast size we see today. Over time, the hot gas thrown out from the Big Bang explosion began to condense into stars. Some of these ancient stars still exist in spherical clusters around many galaxies, including our own. Our galaxy is shaped like a gigantic Catherine wheel. The oldest stars lie in the globular clusters and also in its center. Its outer arms contain young stars, including the sun and dark clouds of gas and dust. This is a galaxy like our own, seen edge on, showing dark clouds like those that mottle the Milky Way. If we could see our own galaxy in a distant aerial view, it would look something like this impressive spiral. But galaxies come in other styles too. This shapeless scattering of stars is a dwarf galaxy, little more than a loose star cluster. Two small galaxies called the Magellanic Clouds accompany our own galaxy, and this is the larger of them. This small spiral seems to have been pulled out of shape by the gravity of a passing galaxy. Some spiral galaxies have a straight bar of stars and gas across their centers. Pink clouds in the arms of spiral galaxies are clouds of hydrogen gas called nebulae, from which new stars are born. Here in close-up are fields of bright nebulae in our own galaxy. These dark streaks are clouds of cold gas and dust seen in silhouette against the brighter gas, which is lit up by the hot young stars born within it. Other types of nebulae mark the end points in a star's life. Here are the remains of a star that ripped itself to pieces in a supernova explosion in the constellation Cygnus. This dying star lost its outer layers in a celestial smoke ring that surrounds it like a wreath on a grave. This family of hot, young stars, called the Pleiades, or Seven Sisters, is still surrounded by traces of the nebulae from which they formed. Within this foggy nebulae lies Antares, the brightest star in the constellation Scorpius, the Scorpion. Antares is the type of star known as a red supergiant, a bloated sphere of gas 400 times the diameter of the Sun and 10,000 times as brilliant. This is how it might look from close up. Stars are gigantic nuclear reactors, turning hydrogen into helium at their centers, and it's the energy released in this process that makes them shine. Like all stars, Antares began its life when a cloud of gas and dust shrank and heated up and began to glow. A star as massive as Antares would at first have been hot and blue, like the stars in the Pleiades cluster. Then, as the star got older, it would swell up and turn red, as we see it today. Eventually, when it has used up all the fuel at its center, it will explode as a brilliant supernova, scattering its outer layers into space, but possibly leaving behind a tiny, fast-spinning core known as a pulsar, with as much mass as our sun squashed into a ball smaller than a city. A pulsar gives out flashes of radio waves every time it spins, like a celestial lighthouse. But sometimes, if the star's remaining core is heavy enough, it will shrink down into something far smaller and denser than even a pulsar, a black hole. Black holes are drain plugs in space from which nothing can escape, not even light. However, gas can be drawn in to the otherwise invisible region. Some black holes orbit around normal stars. Here, gas is torn off the visible star and flows towards the black hole. As it plunges towards the hole, it heats up to millions of degrees and emits X-rays, which can be detected by satellites in space. Most stars are not single, like our sun, but come in families, like this pair of stars, orbiting around their common center of gravity. In this example, a normal star is orbited by a small white dwarf. Gas from the larger companion overflows onto the white dwarf, where it builds up and explodes from time to time, producing what's called a nova. The whole process can repeat itself many times. Dark dust clouds like this prevent us from seeing to the center of our galaxy. With the naked eye, we can see a few thousand stars and 5 bright planets, including the brightest of them all, Venus, seen at center right. In the southern hemisphere, we can also see 2 nearby galaxies called the Magellanic Clouds, at lower left and at top right. The most distant object visible to the naked eye is the great spiral galaxy in Andromeda, over 2 million light-years away. But our understanding of the universe only began to develop with the invention of the telescope in the 17th century. Early telescopes, like this one used by Galileo, used a lens to gather light. This is a larger version of the same idea. A rival design that uses a mirror soon became popular because they could be made much larger and hence collect more light. And it's mirror-based telescopes that are most widely used in astronomy today. The large main mirror collects incoming light and focuses it via a series of other mirrors onto sensitive instruments that record and analyze the light. Observatories are located on high mountains and contain an army of telescopes. A large telescope can be pointed precisely at any spot in the sky and track it as the Earth spins. New designs, such as the giant Keck telescope in Hawaii, use mirrors made of many separate segments. These are some of its first pictures of nebulae and galaxies, artificially colored by computer to bring out details. The Keck telescope has a mirror over 26 feet across. By the end of this century, an even more powerful instrument, with 4 telescopes of that size working in unison, will be in operation at the European Southern Observatory in Chile. Most famous of all the orbiting observatories is the Hubble Space Telescope, which has shown us the universe in more detail than ever before. Like a telescope on Earth, Hubble's large mirror collects faint light from distant objects and bounces it into a series of instruments behind the main mirror, including an electronic camera that takes remarkable pictures. These Hubble photos show distant galaxies passing close to each other and perhaps even about to merge to form a supergalaxy. This process could be the secret of galactic evolution. This spiral of bright young stars lies at the heart of a pair of galaxies that are uniting. The burst of star formation that created this spiral was probably triggered by the collision. Even the familiar Andromeda galaxy, the nearest spiral to our own, shows signs of having cannibalized another galaxy. Through telescopes on the ground, its core appears normal. But under Hubble's closer scrutiny, first one, then another center appears. One of them the remnant of a smaller galaxy swept up 1 billion or so years ago, and now absorbed almost without a trace. Our sun was born about 5 billion years ago. About 4,600 million years ago, a cloud of dust and gas in our galaxy collapsed to form a new star, our sun. Around the young sun, a disk of leftover gas and dust gradually collected into clumps. These became the 9 planets, including Earth, that make up the solar system, all in orbit around the sun. In the past 3 decades, space probes have explored all the planets in the solar system except distant Pluto. Among the most successful of these probes have been the 2 Voyagers, launched to study the outer planets. They were launched from Earth in 1977 on a journey that was to take many years, first flying past giant Jupiter and then Saturn, the planet with the bright rings. The second Voyager then went on to look at the remote and mysterious planets Uranus and Neptune. Their jobs done, both Voyagers are now heading out of the solar system forever and into the galaxy. Interstellar emissaries from the planet Earth. Who knows whether they may one day be intercepted by some alien civilization, if any exists out there. In order of distance from the sun, the 9 planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. The only one on which life is known to exist is the Earth. The 4 planets closest to the sun are small and rocky. The Earth, seen here at lower right, is 3rd in line and appears blue because of its oceans. Farther out are the 4 large planets of gas and liquid. Jupiter, top right, is the largest, and Saturn, with its rings, the most beautiful. Pluto, lower left, is a small icy oddity at the edge of the solar system, orbited by a moon half its own size. The hub of the solar system is the Sun, an ordinary star 100 times the width of the Earth. Energy is released from the nuclear furnace at its center and flows out to the surface. Seen in X-rays, the Sun is continually racked by storms and explosions. Each bright spot is like a cluster of hydrogen bombs going off. In close detail, the Sun's surface seethes with tiny bubbles of hot gas, rising to the surface like water boiling in a pan. Larger dark patches are sunspots, areas of cooler gas, each one large enough to swallow the Earth many times over. A total eclipse. The moon covers the face of the Sun, blotting out its light, and around the Sun's rim, a misty halo of faint gas comes into view, called the corona. With the Sun's glare obscured, huge glowing clouds of gas called prominences can be seen arching into space around the Sun's rim. They dwarf the Earth. Filmed in close-up in the light from hot hydrogen, brilliant explosions called flares rip across the Sun's surface, sending out streams of atomic particles that affect the weather on Earth. When the atomic particles from flares reach the Earth, they cascade down onto the atmosphere to cause a glowing ring around the magnetic poles. Seen from below, this colorful atmospheric glow is sometimes known as an aurora. Mercury, closest to the Sun, is the smallest planet apart from Pluto. It's an airless and waterless ball of rock, only 50% bigger than our own moon, which it closely resembles in appearance. In 1974, it was visited by the space probe Mariner 10, which took these close-up pictures of its cratered surface, scarred by meteorites that have battered it over billions of years. On this hostile surface, blasted by lethal doses of high-energy solar radiation, daytime temperatures rise high enough to melt lead. Venus, the brightest planet in our night sky, is the Earth's twin in size, but very different in other respects. Clouds of yellow sulfuric acid shroud its surface from our view. But radar can cut through the clouds, revealing meteorite craters, volcanoes, and valleys. This computer-generated ride over Venus was assembled from radar images taken by a space probe in orbit around the planet. The roughness of the surface has been exaggerated to emphasize the features. Sulfur clouds cast an eerie yellow glow over the landscape. Under the dense atmosphere, temperatures are as hot as an oven, and the pressure is crushing. Nothing could live on Venus. seen here in a computer-simulated flypast, is the Earth's nearest celestial neighbor. Meteorite craters and dark lowland plains scar its gray and lifeless surface, which has scarcely changed for billions of years. What a contrast with the Earth, a welcoming world of blue oceans, white clouds, and colorful continents. There's Australia, Africa, and South America. Here, photographed by a space probe called Galileo, is the first ever view of the moon moving around the Earth. Let's see that again. And here, also from Galileo, is a close-up of the rotating Earth. Note the sun's reflection off the Pacific Ocean and from rivers and lakes in Australia. The moon is so large in comparison to the Earth, about 1/4 its size, that some astronomers think of them as a double planet. Mars, half the size of Earth, is covered with rusty red deserts. Dark markings on the planet were once thought to be fields of plants, but are now known to be simply outcrops of rock. Space probes have landed on Mars to search for life, but found nothing. Mars has 2 white polar caps, much thinner than the polar caps of Earth. Space probes have mapped Mars from orbit, revealing giant craters, volcanic mountains, and a rift valley long enough to span the United States. This flight over Mars was generated by a computer from space probe photographs. There's the Rift Valley below us. Here's a volcanic peak with a huge crater on its summit. And there are 2 more, all in line. Jupiter, the largest planet, 10 times wider than Earth, is wrapped in colorful bands of ever-changing cloud. The only permanent feature is a huge oval called the Great Red Spot. Beneath the clouds of Jupiter is an ocean of liquid hydrogen. In this Voyager sequence, the Great Red Spot reveals its nature as a spinning storm, large enough to swallow several Earths. Beyond Jupiter, Saturn, second largest planet, ringed by countless chunks of ice and rock. Voyager skimmed the outer edge of the rings. Saturn's atmosphere lacks multicolored storms like those on Jupiter because high-altitude haze obscures them. But computer processing and artificial color brings out subtle cloud details that would otherwise remain unseen. Saturn's rings, at first sight like smooth sheets, broke into thousands of narrow ringlets under the close scrutiny of Voyager's cameras. Again, the colors are added by computer. Here, two small moons orbit either side of a ringlet. And here are dark patches on the rings, caused by overlying clouds of dust. Saturn has more moons than any other planet. At least 20 are known. Uranus and its rings presented a bullseye appearance to Voyager. The planet was toppled on its side by a gigantic collision long ago. Voyager's first pictures showed only a featureless blue disk, but computer processing revealed cloud bands around the pole that points to the sun. And as it passed Uranus, Voyager looked back at the thread-like rings that girdle the planet's equator. Voyager's final port of call was Neptune, another blue-colored planet with narrow rings, in the dark outer reaches of the solar system. From here, the sun appears only as an intensely brilliant point of light. One target of special interest for Voyager was Neptune's largest moon, Triton. Voyager's pictures are the best views we are likely to get of Neptune for a very long time. The dark cloud is Neptune's equivalent of the great red spot on Jupiter. A Neptunian storm cloud with a bright center, like an eye. Ribbons of white cirrus. Voyager homed in on the faint rings of Neptune. Here, the planet's bright globe has been blocked out to show the rings better. Pluto, only discovered in 1930, is never well seen from the Earth. This is the best Earth-based view of the planet and its moon, Charon. The Hubble Space Telescope shows them separately for the first time. Pluto is an icy body smaller than our own moon and probably similar to Neptune's moon, Triton. Its moon, Charon, is half its own size, and at times the two can eclipse each other, as in this simulation. On their way out of the solar system, the two Voyagers are still sending back information about the space around us. They are now approaching the boundary of the solar system called the heliopause, where the gas flowing out from the sun finally meets interstellar space. Eventually, we will lose touch with the Voyagers as their radio signals fade out with distance. But it has been calculated that 40,000 years or so in the future, one of the Voyagers may pass within sight of a dwarf star in the constellation Ursa Minor. If we could ride on Voyager with a telescope, this is what we might see. By then, of course, humans might already be out exploring among the stars. Their first call would be at the star closest to us, Alpha Centauri, which actually consists of twin sun-like stars in mutual orbit, accompanied by a smaller and fainter red dwarf, Proxima Centauri. There are no planets around Alpha Centauri that we know of, but astronomers think that other solar systems may be common. The wings, on either side of this star, are thought to be a band of dust and gas forming into new planets. The star itself has been blocked out, and the colors are artificial. This computer simulation shows what the star might look like close up. Planets are thought to be forming from the spinning disk, like they did around the sun. New stars are being born all the time in places such as the Orion Nebula, to replace those that grow old and die, as our sun inevitably will. Our sun began shining nearly 5 billion years ago. During that time, intelligent life has arisen on Earth. Currently, the sun is in stable middle age. But when its hydrogen fuel starts to run out in a few billion years more, it will swell up into a red giant up to 100 times its present size, swallowing the inner planets and ending all life on Earth. As it dies, the bloated sun will lose its outer layers, and its remaining core will shrink down to a tiny white dwarf. Like the one at the center of this nebula. Even 5 billion years from now, when the sun has died, there will still be plenty of new material to make more stars in nebulae such as these. And what will be the fate of the rest of the universe? Astronomers are now discovering a remarkable fact. The visible galaxies represent only a small fraction of the total mass of the universe. Most of the mass of the universe is contained in the form of dark, invisible matter that does not show up on photographs. If there is enough of this dark matter, its gravitational pull could affect the fate of the whole universe, slowing down the current expansion and eventually reversing it, so that all the galaxies fall back together again. Perhaps, billions of years in the future, there will be another Big Bang, creating another universe with lots of new wonders to explore.
Science Frontiers continues on TLC.
From them, a steady stream of subatomic